Find the domain of each function. So here we're just going to find the domains of these functions. So domain simply means all possible x values. That's what we're looking for here. So when I look at this first one here, hopefully we realize that anything under this square root cannot equal a negative number. 0 is okay because the square root of 0 is 0, but it can't be negative. Okay, so what that means is whatever's under there has to be greater than or equal to 0. And all I have to do here is just solve this inequality. So first I would subtract 4. So then I get negative x is greater than or equal to negative 4. And then I have to divide by a negative 1 both sides. And do you guys remember when I'm dealing with inequalities, that's the only time I have to flip my sign, is when I multiply or divide by a negative number. And since I'm dividing by a negative 1, that inequality has to flip. So I get x is less than or equal to a positive 4. So if I think of my domain, I would just think of a number line and always read this from the variable side, because the variable could be on the other side. That actually says the same thing. Might look a little weird, but it does say the same thing. And you can think of this on a number line. So here's my number line here, and I'm going to put that 4 on there. Okay, now if I read it from the variable side, this is going to say x, and look at the point is towards it. So that means that x is less than, because I don't know if you know this or not, but you can think of this like an alligator mouth. And it's going to eat the bigger one. That's how I heard from a student some years ago. I didn't learn it that way, but I thought that was pretty interesting. So the gator's going to eat the bigger one. So this is saying x is less than or equal to 4. So since x is less than or equal to 4, if I look at the number 4, what's going to be less than it? So that's going to be anything on the left. And notice there, it also has an equal sign on it. So that means it includes it. So that means I'm going to have a bracket there. So the smallest value I'm going to have for my domain then is negative infinity, because it's going to go all the way left. And then it's going to go up to 4 and include the 4. So that's going to be the domain. I kind of wrote it on the other side, but hopefully you're okay with that. That's the domain. Okay, let's move on to the second one now. Now for the second one, the only thing that's going to give us issues is where the bottom would be 0. That's it. If the bottom is 0, it's undefined there, and that's the only place it's undefined. So all possible x values would be okay except for wherever the bottom is 0. So all I have to do here is kind of like the previous one, is I just write that condition in terms of mathematical symbols. So where is 3x minus 2 equal to 0 at? And then what I'll do is I'll add 2 and divide by 3. So that's going to be 2/3. So where x is 2/3 is where the bottom is 0. So x cannot equal 2/3. So everything else is great except for that 2/3. And it doesn't matter what the top is if the bottom is 0. The top will be just 4 times 2/3, which is still some number. Top's not 0 either, so that's going to be our domain. So we're going to jump this 2/3 in our interval. So for this domain, and this is where it gets a little fancy at. Okay, so we're going to go all the way to negative infinity, right? Because we can go all the way left. We're going to go all the way up to 2/3. And remember, we're not going to include the 2/3, so we're going to use a parenthesis there. And then we use this union here. And then we're going to go all the way up to 2/3 on the right side here. And so I'm going to use a parenthesis 2/3, and then I'm going to go to infinity there. That's how we actually jump a number. So we use parentheses on those, and then we, in a sense, jump it. So this is going to go up to 2/3 on the left side. This is going to go up to 2/3 on the right side, not including 2/3 on both of those. So that's how my interval is going to work for this one. So my domain is going to be negative infinity to 2/3 union, parenthesis 2/3 to infinity. I had to move it below for room for the next one. Okay, so anyways, let's take a look at this one. Now, if you're familiar with these functions here, that's what we call a parabola. Now, with any parabola, they open up, they open down, and that's about it for us in Math 122. That's all we get. Now I can move this to the left, I can move it to the right. So this is just a graph, but notice no matter what my quadratic function is or my parabola gives me here, it's always bowing outward and it's including everything in between. So I'm going to go all the way left and all the way right with these, with any parabola. So therefore it's going to be from negative infinity to positive infinity for the domain for that one. Okay, now let's take a look at this last one here. So just kind of like number B here, this is going to follow the same pattern. So the only thing that's going to give us a problem is where the bottom is 0, because I have the variable down there. So I can plug in anything for x, and whatever gives me 0 down there is going to give us problems and can't be defined for the function because I can't divide by 0. That's what's going on. So this is only where x is 0 at. So x cannot equal 0. So now for the domain, I'm going to jump that 0 just like I did on B. So this is going to go from negative infinity to 0, not including 0, union, not including 0 again, to infinity. So there's the answer for number D. So now we finished this problem here. We found the domains of each of these functions.